Hello. Um, so today I am going to go over questions I got, and well, we'll see how these questions go. The first question today was okay. So the first question that I had was about taking a determinant. So I had a question: what is the determinant of matrix? Determinant. These vertical bars mean on the end. Or if I use round parentheses, the matrix, you just have vertical bars, it means determinant. So let's take this determinant. I'm going to have to flip some. So I'm going to take three products. Those are the positive products because they go down and right. First one we'll do is -4 times 4 times. Next one we'll do will be -3 times 3 times -7. The last of positive products, the ones that go down to the right, will be -1 times -3 times. Then we want to do all of the products that go down and left. These ones are called the negative products. They go down and left. And so calculate those. We subtract each of them. Minus, we get -1 times 4 times 7. Go down to the left. We get minus -3 times 3 minus 3, 4. By each of these. 4 times 4 is 68. The two negative signs here are going. I get plus. Here I have 3 negative signs, so 1 negative sign. Here I get -27. Here I get negative, again, 4. Ow. Lots of negative numbers. So let's start combining these. I suppose 20 plus 1. Then we have -48 now combined a lot of the numbers. We'll have that positive. So from here, positive 16 minus 63, 3 minus 16. This, negative 13, negative 9. That is not what my calculator. I made an error somewhere. First off, did I copy this? 4, negative 3, 7. 3, 4, negative 1. Copied. Find the correct products. Negative 4 times 4. That is this one. Negative 3. This one. And negative 1. Got it. That should be a negative. That means that here, this is not negative 28, but negative. That should 12. Problems. Negative 1. Negative 7. 3, negative 3. Positive 3. 3. Negative 4. Everything else looks okay. Okay. And rather than try and fix it, we have negative 48 plus 63. That's going to be created a hotkey brush, but it's next to the hotkey button to have, sorry, negative 40. Then, minus 12 gives us 3, minus 20, minus 27, 8 gives us negative 45, gives us negative 9. All of the checked all of entry. Feel pretty good about it. I code my calculator. Might have done. Let's check a different, better than the have 4. No, this is what I put in. -3, -7. It gets the same thing as the code that I wrote. So there's probably an error in the 12 and oh, this is the work. Okay, by hand. -4, -3, -1, -3, 4, 3, -7. Have 4 times 4 times 3 is 48. Negative. Then we have 3 times 3 times 7, positive 3, -3. Those are our positives. Now we have our negative products. -1 times 4 times -7 is 3 times 4 times 4 gives us 8 again. I think the lesson to learn here is that almost always better start over rather than try and fix it. 3 minus 8, 60, 30. 8 is 35, and negative 35 minus 39 is negative. That's what my program said. That's what this online calculator said. And I feel pretty good about this. Wow. Messed up the determinant twice in a row. It's okay to make mistakes. And fix it. So let's that was one question. Next question was have this problem. Okay, so image will have this partial fraction problem. Asked what's wrong with it. Student said that the code that I wrote said the answer -6 for the problem, and that got positives. And the reason is the problem I wrote was 9. and the student copied the problem wrong. That's probably. Let's do both of those problems. Problem. Student wrote down 9x over x plus 1, and got a partial fraction x over x1 plus 4 great. Here, we're going to multiply both sides. Cancels the right side. We're going to get partial. So, what's going to happen is x in the there as giving us also gets partial. We have a few nice options for eliminating. The goal in this problem is to let x left side is going to be 9 times get a times plug in x is 0, I get 8 times negative 1. That turns 0, so 0. Same over here. So this means a. On the other hand, let x equal the left side of the equation minus 6. This turns into this turn. So does that. That leaves 3 equal halves. And if we let x equal negative 1, we'll be able to find left we get negative 9 minus. On the right side, we get that equals 0. And this one divided by, and now that we know 6 over x 1 now. That's the problem the student got. The problem they were supposed to do had a positive. I think it's much the same. I don't necessarily have to do it. So let's figure out some more questions. Bad. Okay. So I remember. So it has to do with compound interest, and we have a person buying a car. They're going to make a down payment of $4,500, and they're going to buy a car for 13,900. Um, I suppose that's the price. Car, and then um, this person is going to get a 3.5% interest rate, and they're going to have the loan for. So, assuming that this is a compound interest loan, which is not entirely normal, compound interest loans, you have the interest, all of the loan being paid back on the last day of the loan. But normal loans, you have to make monthly payments. So it's a little bit unrealistic, but makes the math a lot easier. And it's pretty close for getting the concept of how the interest on a compound loan, or the loan that we're normally used to, I think, is called an installment. Anyway, we want to figure out how much this car is going to cost in total. We're going to figure out how much interest we're going to pay on this loan, and we're going to figure out the total amount paid on the loan. So our formula is going to be the amount that you pay back on the loan is equal times 1 plus the rate over the number of compounding periods per year raised to the number of compounding periods per year times the number of. But for this loan, we're going to assume yearly compounding. That means equal 1. It means it just basically, and we're going to plug everything up. So the principal is going to be the cost of the car minus the down payment. So we get 900 minus 500 is 13 minus 4 is. So the loan amount is going to be for that. That's the. So we get. Don't know how much we're going to end up paying in the end on the loan, but it's going to equal 9,400 times 1 plus 3.5% is going to be 1.035, as it is 1 here, raised to the n is still going to equal 1 times the number. So let's pull up a calculator. How this go? So we're going to type in um, 1.035. Going to raise that There we go. We get this, and then we're going to multiply that by going to get 1,000, 11,555. It'll round down to no cents. So this is the total amount paid on the loan, but it is not the total amount we will pay for the car because we also made a down payment. So the total amount for the car is the total for the loan plus the down payment. Get like 1,055 cents. And we're also asked to figure out what the interest is going to be the total for the loan minus the, so that out, the total amount we pay for the loan minus 1,004 gives us 5 minus 1, 11 minus $1,001. So those are the two things it has to be able to compare. Total for the car and the amount of interest. Take a little look at shadows. Probably in our next. Okay. So question 1. We have triangles. So one triangle. Hold the. Oh, I don't think we're told that the similar. Second, about if these triangles are not guaranteed similar, then there's really nothing we can learn about. So they have to be. Yeah, I think that that problem probably has to be written. We're going to assume similar sides so that we can. So if they're similar, then we get some correspondence. We have 10 times 6 is 60, 9 times 6 is 4. So 6 times x has to be 30. Means that x has to equal. And that makes sense. If the short side is half the long side, then the short side will also be half of the long side in this. We have another one. Hold it's 8x 12 compared to 3. Well, if this ratio is this ratio, then this ratio x equals. Like we have a few of these. Scroll down a bit. They're all similar triangles, setting up. Our first non-triangle, some sort of quadrilateral. Where it goes 4, 7, and so if ones are 14 by 7, then those ones are 126. 2x equals 6. So this should be we have another quadrilateral. Then we get to measuring the height of a tree. We have a picture of a tree, and we're told that distance from the base of over here. Oh, the sun is over, casting a shadow. So the length of the shadow is 15 meters. We have something stuck in the ground. Oh, it says it's a pole. 3 meters tall. That's a 4 meter shadow. So that means that x over 54, x equals, which is 45 over 5. The next one says Sarah wants to find the height of a flagpole at her school. She knows she's 5'6" and casts a shadow of 3 feet long. The flagpole casts a shadow that's 11 feet long. Want to draw a picture? Help Sarah find the height of the flagpole. That here's the flagpole. We don't know how tall it is. Has an 11-foot shadow. Sarah is 5.5 tall. Casts a foot shadow. So here's the pole. Here's Sarah. And yeah, all we do is we know over 11 equals 5.5. That means times that get 05. 5, 5. 5 over 3, which is some. But we can leave it. 05. Okay. Now we have a mirror problem diagram here that I'll get. So have this mirror on the ground, base of a geyser. walks backward until he can see the top of the geyser in the middle of the mirror. He measures that he's 7.5 measures that he is 7.5 feet away from the mirror. His eyes are 6 feet above the ground, and he wants to figure out how big the geyser is. So, mirrors reflect light at the same angle that they receive it. So, this angle is the one that's 90. That's 90. These angles are the same. Those angles are the same. These are similar. We have 6 over here, a 7.5 over here. I don't know over here. You know, you can set this up a bunch of ways. I think that x over 6 has to equal 7.5. I multiply both sets by 45 times 6 over 7.5. 45 times 6 is the same as 7.5. And I feel okay about plugging that into a calculator. Calculate 70 divided by height of the geyser is 36. We have another one where instead of having a geyser over here, we have a giraffe. Trying to measure how tall the giraffe is. Done the same way. We have one where we have a mirror on the ground, and instead of having a giraffe or a geyser, we're measuring the Eiffel Tower. Either way, it's the same problem. The two triangles are similar, so we can sides. The important thing with the ratios is that I have to keep categories lined up correctly. So, like for instance, um, my categories on this problem that we did, where we had the geyser and the person were on the ground between them, I have distance from for the guy away from the. I guess we have Parker's distance from the mirror and Parker's, and we have the geyser's. So as long as my combinations are like height of geyser, height Parker, they're both over the distance geyser distance. Like I've chosen to have objects have to line up vertically. Geyser, Parker. And then I'm doing the types of distances. Heights are on top, lengths are on the bottom. Like as long as I line it up so that you know two of the category like two of the categories that correspond are vertical, the geyser versus Parker, and the other two categories are horizontal, like the heights and the distances, then my proportions. I could switch it around and say, instead of having geyser height over geyser distance, Parker height. I did geyser height over Parker height equals geyser distance Parker distance. I could have easily done it this way as well. Geyser height over geyser distance equals Parker height over Parker distance. And that would also get me this. I would be having the geysers vertically and the geyser and Parker and the heights and the distance, or I could set it up how I did, which has um, heights are vertical and the geyser. Either way works just fine. Um, I like to try and put it to the variables in the numerator, just because that reduces the number of multiplications and divisions that are needed to finish the problem. But up to you. And, you know, the way you figure out to solve a problem is the best one. Like, even if there's a more efficient or more elegant solution to a problem out there, if you don't think of it, then it doesn't matter. But if you think of a solution, it doesn't have to be the prettiest solution. It doesn't have to be the fastest solution. If it gets you the right answer, it's a good solution. So, that's the time I have today. That your classes are going well. And if you have more questions, I will be live streaming again. I think I can do tomorrow afternoon. Send a message out. But luck on all of your exams and all your studying. Have a great day. Bye.